Hello. So we'll be looking at the KVPY 2019 essay stream physics solutions. The first question was about the rainbow formation. What are the sequences followed there? The first one will be the diffraction, and then the total internal reflection take place in the diffraction. A very straightforward question, though. So the option would be A. The next one is the main scale division. The least count of vernier caliper is 1 mm. So the 10 divisions of vernier caliper coincide with the what do you say, the 11 vernier scale divisions. So the length should be same. Let the least count of vernier caliper be LCV, then we get it as 0.1 mm. So the correct option would be option A. Going on to the next question. Next question would be the 18, the question number 18 was slope of the velocity curve. The slope will be the displacement time graph. The slope of displacement time graph would give you the velocity. It is 5 units on the y, 3 units on the x. So 0.1 unit by 0.3 units, 1 by 3 meter per second, which is 0.33 meter per second. So terminal velocity is 0.33 meter per second. So correct option B, option B. The power requirement, the question number 19, the 1 kVA can be translated to 1000 watts. The total power consumed by the 10 laptops would be 90 watts each, 10 into 90, which is 900 watt. Sorry for the interruption, it is 900 watt. And since it is 900 watt, so the total energy consumed is 1 kilowatt hour per unit is 5 rupees cost. So for 900 watt into 5 hours, so for 4500 watt hours, what would be the charge? So 900 into 5 into 5 by 1 kilowatt hour, which is 1000. So the correct option would be 22.50 units, 22 rupees 50 paisa would be the total cost. So one option, the first option and the third option are correct. So 1 and 3 are correct. So option C is the right choice for the question. So the next question is about the how is a frosted glass rendered transparent by just adding an adhesive glue, because the refractive index of the adhesive glue and the frosted glass are the same. So it rendered, so the ray coming or the incident on the frosted glass or the adhesive tape will be transmitted. So it is rendered transparent, so due to refractive index matching of, whenever refractive index is the same, it passes through undeviated, right? So it passes through undeviated. Therefore, the n1 equal to n2, refractive index matches. So option C is the right choice. Question number 21. One prism is filled with some liquid, other prism is filled with another liquid or the same liquid at another temperature. Since the refractive index of the two are not the same, there will be a dispersion. If they are same, then this is just a glass slab combination, so it will pass through without any dispersion. So the correct option will be option D, where A is filled with the hot water and B is filled with cold water. Then there is a refractive index mismatch, due to which this will not behave as a glass slab combination. So there is a dispersion. So next question is question number 22. In 8.3 seconds can be written as 1.5 into 5 plus 0.8, which means it revolves around circle 5 times, and then in 0.8 seconds it comes up to here. The displacement or this straight line distance is nothing but 2r sine theta by 2. Since this 2r sine theta by 2, theta would be 360 degrees by 1.5, which is the time taken, into omega t. This is omega, this is t. So sine theta 360 by sine theta by 2 would be 180 degrees into 8 by 15, 96 degrees, which is cos of 6 degrees. Sine of 96 degrees same as cos of 6 degrees. 2 cos 6 degrees. Since 6 degrees is a very small angle, we can approximate it into 2. So this displacement is approximately 2 meters. Since this is an isosceles triangle, remember this is an isosceles triangle, so 1 meter and sine theta by 2 would give you half of this, so total would be 2r sine theta by 2. Moving on to the next question, which is question number 23. In question number 23, we have the energy conservation. This is given a small hemisphere, a particle from here slides down here and it drops off, or it loses contact with the hemisphere. So what is the velocity here? The initial potential energy is mgr, now it is mgh. So velocity here would be half mv square. V is equal to root 2g r minus h. So correct option is the option A. Coming to question number 24, R is equal to R naught A power 1 by 3. Mass of any nucleus is atomic number in mass number into number of protons. mass number into number of protons. So it would be V is 4 by 3 pi r naught cube. R naught cube A is because it is, we know radius is r naught into a power 1 by 3. So volume is dependent on A, even mass is dependent on A. So the density does not depend on A. So it is uranium. Even for uranium as well as tin, it is the same thing. So option C, which says that the density of both of them is the same, is the right option. Moving on to question number 25. In question number 25, we have the electrostatic energy thing. Initially, the volume of the parent nuclei is equal to volumes of the daughter nuclei. So volume remains constant. So 4 by 3 pi r cube is equal to 2 times 4 by 3 small r cube. Small r is the radius of a daughter nuclei. So capital small r is equal to capital R by 2 power 1 by 3. This is the relationship we got. They are asking the electrostatic energy of the change in electrostatic energy. Electrostatic energy depends on the charge and the radius. So the charge is Ze by 2 and the radius is R by 2 power 1 by 3. So for two daughter nuclei, the total electrostatic charge energy would be 1 by 2 power 4 by 3 k z square e square by r. So what will be the change? Change is 1 minus this quantity. 1 minus this quantity, which will be further clear in the next page. Next page we have this. So 1 minus 2 power 4 by 3, with the answer comes approximately equal to 0.375. 0.375. The next question is, there are two charged masses. The two charged masses are Q1 and Q2. There is an electric field upwards, which is E, and then a mass M1 drops first and later comes M2. So the acceleration of M1 downwards is greater than acceleration of M2 downwards. By that I mean G minus Q1E by M1 should be greater than G minus Q2E by M2, from which we get Q1 by M1 should be less than Q2 by M2. So M1 Q2 should be greater than M2 Q1. So option D is the right choice. Moving on to the next question. The next question, PV is equal to RT, the ideal graph equation. So how is the graph would be compared to PV is equal to T? So Y is equal to MX graph, so R is 8.31 here, so slope here is big 1. So slope of 1, which is this graph, would be greater than slope of 2, which would be this. So for it is greater than 45 degrees. So the right option would be option A, which says the graph of 1 is more inclined to the x-axis than option 2. Second graph. Moving on to question number 28, the annual demand in number of liters of rain in Mumbai would be 14 into 10 power 8 meter cube. Remember, we need to convert everything into meter cube because it's given in liters. So we know 1 decimeter cube is 1 liter. So 14 into 10 power 8 meter cube is the annual demand. So the next thing would be, since the demand is this, the volume of rain received would be 6 into 10 power 7 into 24 meter cubes. 10% of this volume would be 144 into 10 power 6, 144 into 10 power 6 meter cube. So the percentage, if you convert, it would be 144 into 10 power 6 meter cube by 14 into 10 power 8 meter cube into 100, because it's percentage. We get 144 by 14, 10 power 8, 10 power 8 is the same. So we get 144 by 14, which is 10%. The 10% of Mumbai rain demand will be, of Mumbai water demand will be met by the rains. So moving on to the next question, question number 29. We have elastic collisions. In elastic collisions, what will happen? Energy in elastic collisions, not inelastic, it is in elastic collisions. We have kinetic energy as conserved. This is a momentum conservation law. Initial momentum is capital M into V, final momentum is mv prime plus m nu. Initial kinetic energy is half mv square, final kinetic energy is half mv prime square plus half m nu square. So we get a relation as if you try to bring this here, we have mv square minus v prime square is m nu square, but we can simplify v square minus nu square as from here, because we know m into v minus v prime is m nu, m into v minus v prime is m nu. So it is, we substitute directly m nu here. So m nu into v plus v prime is m nu square. So nu is equal to v plus v prime. V plus v prime relation. So option D is the right choice. Moving on to question number 30. In question number 30, it is about all thing is about TIR. In TIR, we have the incident beam, which is incident normally is totally internally reflected. Then only it will come from QR. If not, it will just refract through PR. So the condition for that is mu I sin theta should be greater than 1. So mu I sin theta should be greater than 1. I mu I is the refractive index of the beam for the of the prism for each of the wavelengths. So mu I by 2, because sin theta is 30, sin theta is 1 by 2 because it's 30 degrees. So mu I by 2 should be greater than 1, or refractive index should be greater than 2. So why sin theta is 1 by 2? Because since the isosceles triangle, if this is 90 degrees, this is 30 degrees, so this will be 60 degrees. This angle is 60 degrees. So this angle between the normal and the incident ray would be 90 minus 60, which is 30. So this angle is 30. Okay. So if this angle is 30, applying Snell's law, we get this condition. So mu I should be greater than 2. Of the given choices, only 3 and 4 rays have refractive index greater than 2. So only they will totally internally reflected, and they will come out of QR. So option C is the apt choice for the question. Moving on to next question. Next questions are the 2 markers. The first question in the 2 markers is question number 66 in part 2. Again we have TIR phenomena. A laser pointer is rotating. The laser light will escape only if the angle of incidence is greater than theta c degrees. So we have to find the time taken by the laser pointer to rotate theta c degrees. There is no need to use all the 40 meter, 10 meter thing. We need to find only the angle theta c. The theta c angle would be 1 by 1.33 by using the Snell's law. So sin inverse 1 by 33 in degrees. So what if it takes 60 seconds to rotate 360 degrees, then how much time would it take to rotate theta c degrees? We get the answer as theta c by 6 degree seconds you get to rotate, you take to rotate theta c degrees, but we need to find twice of that. Why? It will rotate like this, then again it will be invisible for this much time, and again it will be visible for this much time. So it will be 2 times the time taken. So it is theta c by 3 seconds. So theta c is what? We know it is 48.6 degrees for water surface. So 48.6 by 3 is 16.2 nearby seconds. So the right choice would be option C for this question. Here we need to know only if till theta c we will find that the water is escaping from this, otherwise it will be totally internally reflecting. Okay, total internally reflecting. Then we move on to next question, question number 67. In question number 67, we have to find the force exerted by the sand. So force is given as the rate of change of momentum. Since the velocity is constant for each sand hitting the bottom, we have dm by dt. Dm by dt is nothing but the mass flow rate, which is number of sand grains into 0.2. 0.2 is the mass of each sand. 0.2 into 10 power minus 3 kgs. So 2 into 10 power minus 2 kg per second is how the mass is coming. So that multiplied by the velocity of each sand particle after it fell through for 2 seconds. V is equal to gt. So velocity of each sand particle will be 10 into 2 seconds, which is 20 meter per second. So if we put in this formula, we get 2 into 10 power minus 2 into 20, which is 0.4 Newton. 0.4 Newton is the force exerted by the sand on the flask. Next question is ammeter and voltmeter question. Here no need for us to go to this question to the first scenario, but still we have to see how does it work out. We reduce the question into this, which they are expecting. The voltmeter connected with the internal voltmeter resistance in parallel, and ammeter connected with the internal resistance of ammeter in series. This is the key thing to figure out. So after this, what we do is we go on to the second diagram where we get a very better this thing. In the second diagram, here voltmeter is connected in the parallel to RV and parallel to 1. So the voltage across 1 ohm is the same as voltage across VRV. So current across 1 ohm will be VRV by 1. Current across 1 ohm will be VRV by 1. That current VRV by 1 is VRV. This current plus current across RV. What is current across RV? current across RV would be current across RV would be what? Voltage across RV, it is VRV by RV. So sum of these two currents should be this current flowing through this, which is IRA. So we know by the data given that voltage across voltmeter by current in the ammeter, this ratio is 0.999. 0.999 is, so we substitute VRV as 0.999 IRA and we arrive at the following. RV would be is equal to 1000 ohms. We get RV as 999 ohms, but we will say it is approximately equal to 1000 ohms. So the only option matching with RV is equal to 1000 ohms will be option B. Option B is the right choice. We needn't to work out RA. We straight away we say RV is equal to 1000 ohms. Though we can, by the first figure we can calculate RA, which comes across 0.01 ohms. Okay, so voltmeter ideally it should have very high resistance, so we come to know it is 999 ohms. How? Sum of current flowing through this plus current flowing through this should be equal to current flowing through the ammeter. So IRA, the current flowing through ammeter, should be current flowing through this plus current flowing through this voltmeter, the voltmeter resistance. Okay, moving on to the next question, which is question number 15. I mean the question number 69. The question number 69 has a very cool thing though, which is about a hot air balloon. The hot air balloon is floating, so the net force upwards should be equal to net force downwards. The net force upwards will be buoyant force. The buoyant force will always be given as rho GV. Rho is air density of air outside. So volume of balloon is 4 by 3 pi r cubed. R is 5.85 meters. From the diameter is 7.7. So radius would be 5.85. So P air, pressure of air into molecular mass of air by R into T of air, all quantities with respect to outside, is equal to mg. The mass of payload is 210 kgs plus mass of air inside. So 210 plus ma mass of air inside into g. From here, the calculations from doing the substitutions, we will get 798.6 kgs of air is inside the balloon. Since even hot air is also ideal gas, we put PV is equal to nRT to find the temperature where inside the balloon, which is evident in the next slide. Okay, so question number 69 itself, continuing, we have this. Alright, in the question number 69 we have 798.6 is the mass, kgs. Number of moles would be 26,620. So putting in, and the key assumption is neglecting the surface tension of the balloon material, we have pressure of air inside should be equal to pressure of air outside. So pressure of air inside is the same as pressure of air outside, which is atmospheric pressure 10 power 5 Newton per meter square. So putting PV is equal to nRT, we have N is 26,620, so we get T is equal to 105.8 degrees Celsius, which is the only option which is matching with C. Option C is the right choice. We get 380 Kelvin. Remember, it is in Celsius, so we need to convert it into Celsius. Okay, so 105.8 degrees Celsius, so it is 105 degrees Celsius. Option C is the right choice. The next question, the last question, the 2 marker, is about the head, heart, leg problem. The head, heart, leg problem, the blood pressure in heart is given to be 13.3 kPa. As we move on to the head, which is 0.4 meters above heart, is the pressure decreases. As we move downwards, the blood pressure increases. So what is the pressure of head? Pressure of head is pressure of heart minus rho g h. H is 0.4 here. Pressure of leg is pressure of heart plus rho g h, where h is 1.3. So we have pressure of leg by pressure of heart, which is the ratio they are asking, is equal to pressure of heart plus 1.3 into rho g by pressure of heart minus 0.4 into rho g. Okay, since rho is given to be, density of blood is given to be 1000 kg per meter cube, because blood is made of water, it is same as water. So 13.3 plus 13 by 13.3 minus 4. Since it is kPa, pressure of heart is given in kPa, I will take this 1000 and that 1000 to be common. So it is 13.3 plus 13 by 13.3 minus 4, which is 26.3 by 9.3, 2.82. The very close answer is 3. So hence option C, the ratio to leg blood pressure in foot to blood pressure in head is 3. So option C is the right choice. So hope you have listened to the solutions very attentively. So I hope you have got very new scenarios, physical scenarios to think upon and develop upon. So keep watching and keep learning. Thank you for watching the video.